Lesson 78, graphing rational functions. So if you remember, a rational function will have a variable in the denominator. So we have rational function has a variable in the denominator. So an example would be f of x equals 1 divided by x. Then we want to remind you that an excluded value is a value of the variable that makes the denominator equal to 0. So in our example, f of x equals 1 divided by x, x cannot equal 0 because then we would have an undefined function. If we had f of x equals 1 divided by x minus 3, we would look at our denominator, say x minus 3 cannot equal 0. We're going to add 3 to both sides and say that x cannot equal a positive 3. And that's and 3 is the excluded value. So here's an example. Find the excluded value in this function. Y equals m minus 4 divided by 3m minus 12. So we look at our denominator and say 3m minus 12 cannot equal 0. When we add 12 to each other, we get 3m cannot equal 12. We divide by 3 and m cannot equal 4. So m equals 4 is the excluded value. Now when we have a function that is called discontinuous, that just means that there's going to be a jump or a break in the graph. So here's one discontinuous function. If we had kind of this sideways parabola and one down here in the third quadrant. Or let's say we were drawing a line and partway through the line we had a break. Let's say right here, x could not be 4. So sometimes we have these boundary lines that functions cannot cross. So on this example here, we had the lines, let's see, the functions never crossed any of the axes. So those lines are called asymptotes. I think everyone should say the word asymptote. Excellent. So it's boundary line that the graph approaches but never touches or crosses. So it never touches or crosses that line. So let's say we had this function y equals 2 divided by x minus 8. If we said our denominator x minus 8 cannot equal 0, so x cannot equal 8, then we can say our asymptote is x equals 8. That's the line that can't be crossed, which is called the asymptote. So if you have an x equals equation, you go over to that number on the x-axis and draw a vertical line. Now we draw it dotted because this is going to show us that our function has to stay away from that line. Now sometimes when we're looking at different graphs that we need to graph, we have what's called a parent function. So a parent function for rational functions is f of x equals 1 over x, or y equals 1 over x. And the way that looks is just like our example up above, where we have a kind of a sideways parabola in the first and one in the third quadrants. So if you notice, our x-axis is the horizontal asymptote. And to write the equation of the x-axis, it is equal to y equals 0. Now the y-axis is a vertical asymptote. And remember, vertical lines are written as x equals. So the y-axis is x equals 0. So these are both asymptotes in our parent function. Now we could say our rational functions are of the form y equals a divided by x minus b plus c. So if we start with our parent function of y equals 1 over x, we could change that one to a different number. We can add or subtract a number from x in the denominator, and we can actually add and subtract a number at the very end, and that's what this a, b, and c means. So the number b is the vertical asymptote. The number c is the horizontal asymptote. So horizontal asymptotes, remember, are y equals. So y equals c is a line that the graph cannot cross. And x equals b is a vertical line that the graph cannot touch. So let's say we have y equals 1 divided by x minus 4 minus 2. So in this case, b equals 4 and c equals negative 2. So b is the vertical asymptote. So we have x equals 4 is the vertical asymptote. And then if we had y equals negative 2, and that's the horizontal asymptote. So let's say we wanted to graph this. We want to graph this whole function. So we're going to make a table of values, and we're going to pick 3 each numbers above and below the vertical asymptote. So in other words, 3 numbers above 4 and 3 numbers below 4. So here's our table of values. We have our x and our y. Our asymptote is 4, so let's pick 1, 2, and 3. Those are all below 4. And then we'll pick 3 above, which is 5, 6, and 7. Now when we plug in 1 for x, we have 1 over 1 minus 4, so a negative 1/3 minus 2 is a minus 2 and 1/3. If we plug in a 2, we get a negative 1/2 minus 2, so it's a negative 2.5. And if we plug in a 3, we have negative 1 minus 2, which is negative 3. And then let's see what happens when we plug in a 5. We get 1 minus 2, or negative 1. A 6 would give us negative 1.5. And a 7 would be negative 1 and 2/3. So to graph, we're going to graph the asymptotes and those points and then connect. So we have x equals 4. So come over to 4, 1, 2, 3, 4. Graph our vertical asymptote. Then we go down to 2 and graph our horizontal asymptote. Then we plug in 1, negative 2 1/3. So 1, negative 2 1/3. 2, negative 2 1/2. And 3, negative 3. So this is going to look like that. It's going to kind of curve this way, which means the other one's going to be up here, but real quick we'll plot those points. 5, negative 1, 6, negative 1 1/2, and 7, negative 1 2/3. So of course this one's going to go this way. And that's the end of the lesson.